Okay, welcome back after the coffee break. My name is Philip Hoffer from the Jody and Schindler Group. I have the pleasure in presenting this IoT session, and I'd like to introduce the first speaker, who we have, Mr. Chee. Chee is currently the senior engineer at the Engineering Technology Department from the Building and Construction Authority in Singapore. He has 10 years of experience in the lift and escalator, and besides actively involving himself in inspectors and investigations of lifts and escalators and amusement rides in Singapore, he also represents the BCA as a member of the working group Lifts, Escalators and Passenger Conveyors, which is involved regular review and prevailing standards for lifts and escalators. He's currently pursuing his MSc in the lift engineering at the University of Northampton. Thank you.
Hi, everyone. Thanks, Philip, for the introduction. My name is Hui. Today, my presentation is on setting standards on remote monitoring and diagnostics for lifts, a Singapore context. So this is the content of my presentation. So I will start with a short background of who we are and where we are from and why we are doing this. Then we will go into the key sections in the code of practice and the key considerations behind them. We'll talk a bit about the R&D trials we have conducted in Singapore, as well as things we are going to do moving forward. Then we will conclude the presentation. So a short background of who we are. For those who are not familiar with us, we are from the Building and Construction Authority of Singapore. We are a statutory board under the Ministry of National Development of the Singapore government. To provide and ensure high safety standards of the built environment, one of the areas that we BCA regulate is lifts and escalator. So in BCA, the people who are responsible for lifts and escalator safety is the electrical and mechanical group. Under the electrical and mechanical engineering group, we have 3 departments with different functions. Besides lifts and escalator, we also regulate amusement rides. So moving on to the presentation, I think all of us are very familiar with the types of maintenance in the lift maintenance sector. We have corrective maintenance, preventive maintenance. So I'd like to draw your attention to time-based maintenance. In Singapore, monthly maintenance is required by the law. So besides monthly maintenance, the lift contractor must also maintain the lift to achieve 20 maintenance outcomes. 20 maintenance outcomes are the standards of maintenance to be achieved by the lift contractors. So earlier I was talking about the 20 maintenance outcome. So this is the list of the 20 maintenance outcomes that we prescribe inside the regulations. So for example, in item 10, you see the brakes of lift machine and drive. So for this, right, contractor have to make sure the brakes are free of oil and contamination, because having that will affect the braking capacity of the lift. So besides time-based maintenance or TBM, we also recognize that IoT-enabled CBM or PDM are getting more and more mainstream. So the advantage of this IoT system, because there's improved safety and reliability of the lifts, technician becomes more efficient because they can now perform targeted maintenance. Companies also become more productive because they can plan for their spare part replacement based on the IoT's recommendations. For the lift owner, they also become more aware of the lift performance. So in this presentation, we refer to IoT-enabled condition-based monitoring or predictive maintenance solution as remote monitoring and diagnostic solution, or R&D solution in short. Oops. So in Singapore, vertical transportation is a necessity. with limited manpower and aging workforce, the challenge is to maintain a safe vertical transportation systems that will continue to grow over time. Inside with R&D, the lift is monitored 24/7. The contractor is now more aware of the condition of the lifts. With diagnostics capability, the lift companies can carry out prediction on the lift data to predict faults or issue with the lifts. Because of this, there's now no longer a need for companies to maintain the lift on a monthly basis. So maintenance can be done as and when required. So in the long term, we believe with R&D, it could be our solution for our manpower challenges in Singapore. So based on our studies and learning trips over the years, we identify the lack of standards as one of the key obstacles in the adoption of such technology in Singapore. So we have developed the standards for R&D solutions together with the inputs of our local lift industry. We also seek endorsement from a panel of international experts. We published the code in August. So the main sections of the codes are described in these slides. We will now take a deeper look into the different sections. So for the first section, we are looking at the data acquisition system. So based on our context and learning from the different solution provider, we learned that there are actually two ways for us to collect data for conditioning monitoring. So conditioning monitoring data, which can be in the form of controller data or sensor data, are all acceptable for us. So I guess some of us will ask, do you have a list of conditioning monitoring parameters? So the answer for us is no, we don't prescribe them because we feel that there are actually many methods around available to collect this data. So, and as technology progresses over time, it may not be ideal to prescribe these points. So from the regulatory and the safety perspective, our approach is to focus on defining the outcomes expected from the R&D solutions. This will be covered in more details in the next slide. So moving on to the next section, which is on the data analytics, which is the heart of the R&D solution. Besides having the machine learning algorithm and the AI predictive diagnosis, we also define what we expect from for this section. So to do so, we work out a list of monitoring outcomes. This will define what an R&D solution should achieve when it performs analysis on the lift condition monitoring data. So to work out this list, we make use of the FMEA approach to decide on the critical list of components that should be monitored and analyzed. So we started in the FMEA approach, we started with identifying the items which are essentially the list of principal components or subsystem in a typical lift system. Then we focus on assigning severity numbers to the items if failures occurs. The numbers are given by considering the safety as well as the operational reliability. So one such example is the door system, since we know that doors are major contributions to breakdown. So item high on the severity index should be monitored and diagnosed. Then we apply a cutoff level to arrive at the final list of monitoring outcomes. So this is here. So these are some examples of the monitoring outcomes that we have worked out. This also ties in very well with the 20 maintenance outcomes that we have mentioned earlier. So R&D solutions that meet the requirements of the code will be able to check on 14 of these items. This will help to reduce the physical checks that technicians need to do every month. So at the end of the code, we include a short section on the performance indicator. So we included them for two reasons. First, we need an objective way to quantify the performance of the R&D solution. This will be done by measuring the reliability of the lifts as well as the productivity indicator. We also included accuracy because this is a criteria that we use to measure the performance of the R&D solution. The second reason we included the performance indicator is because it gives us a consistent way of evaluating across different types of solutions that are available on the market. So we also conducted trials locally in Singapore. They were done on 174 lifts, spread across the whole island. They cover offices and light industrial buildings. So in the trials, the focus was actually to show that the R&D solution is working. So they will be tested on whether the lift faults are predicted accurately, diagnosed under a monthly maintenance regime. So during the trials, it also gave us opportunities for us to refine the requirements inside our standards. The trials also allows the owner and the R&D solution providers to understand the dynamics of the relationship, especially inside a third-party solution provider where there's 3 parties being involved. So you have the lift contractor, the solution provider, and then there's the owner. So there's a interesting dynamics that goes on inside this kind of situation. So for the trials, the result has been promising so far. We have seen improvements in some of the indicators. So there's about an improvement of about 2% for the uptime, as well as a general decrease in the failures per equipment from a value of 0.2. So moving on to remote intervention and cybersecurity. So from our experience so far, there are solutions out there who could actually control the elevator from inside a room or from the internet. These are used to improve the uptime of the lift by resetting them from remotely. So for us, from a safety perspective, we are generally okay with this function as long as it does not affect the user of the lifts as well as the safety of the lifts. Also, given the recent attention to cybersecurity, we realize there's also a need to have a section on this. There are a number of standards on cybersecurity, such as IEC 62443. But we feel that IEC 62443 is the most applicable for R&D and lift system. So we took reference from them in the interim, and then we also will follow the ISO 8102 when it's being published. Moving on, we also have a data visualization platform. We feel this is important to include inside the code because by having information available to the lift owners at real time, there's transparency on the performance of the lifts to the asset owner. So for us, we don't really specify how it can be done. It can be done through a web-based application. It could be done through an internet browser or something like that. So we also have some recommended list of specifications that could be inside the lift visualization platform for such solution. So with this standard, we intend to use them to provide clarity on what is expected for new solutions who wish to be used in Singapore. Also, the standards will help us to provide a basis for a differentiated treatment for remote monitoring and diagnostics lifts versus non-remote monitoring and diagnostic lifts. So moving forward, we will be carrying out further trials on R&D lifts, especially when we would like to check whether such lifts can be maintained at a lesser frequency, such as 3 months or even lesser. So through this trial, we hope to gain more insights on the safety and performance of the lifts, when RMD is applied. So I think the ultimate question we like to ask is whether can maintenance visit be fully guided by RMD and still achieve the same performance. So this is something we are looking at, and we hope to do so in the future. So yeah, this is the last slide for me. Yeah, so in summary, we have shared some key considerations of the code. In particular, we introduced the concept of monitoring outcomes as well as performance indicator. The use of monitoring outcomes is to specify what is the desired outcomes for this solution, and for performance indicator, we use them to evaluate new solutions as well as existing solution in the market. So with that, I come to the end of my presentation.
Right.
Thank you.
Thank you.